Here's a hack. Passing your June examination, it's so important because to many people, you actually use your June examination results to actually apply for your universities. Getting help on physical sciences, it is extremely important, especially if you know that you are having a bit of a challenge. So ensure that you WhatsApp this number so you can get your help when it comes to physical sciences. Everything, any topic that you can think of, it is going to be covered. If you're in grade 10, 11, or 12. Now let's actually look at this wonderful question when it comes to Newton laws of motion. So this topic, it actually covers two grades, grade 11 as well as grade 12. And it is one of those questions that a lot of people do not understand. Let's just look at this wonderful question. Um, there's a lot of information that actually comes with this question. And I do not want to waste time explaining, but let's just answer this question and see where this wonderful journey is going to take us. Guys, they want us to draw the free body diagram as the first question. Drawing a free body diagram is one of the most underrated things you can ever think of. I mean, guys, drawing a free body diagram can give you about 5 marks into the exam, and that is the easiest thing you can ever do. Ensure that you know how to draw your free body diagram by identifying the forces that are present to ensure that you score 5 marks for like free. But let's just start with the 7 kg block. How do you draw it? Well, you realize that you are having the force F. You can just call this one the force of applied, and it happens to be 51 newtons. You realize that you are having the tension acting on the opposite side. This is just going to be the tension. You realize you are having the kinetic frictional force that is acting on the opposite side, so you're going to have Fk. You realize that always we're going to have Fg or gravity, and you also realize that you're going to have your normal force. This is N. So this is your free body diagram for the 7 kg block. But what if you want to draw the free body diagram for the 4 kg block? How do you do it? Well, you're just going to start with your dot, and then you realize you are obviously having some sort of tensions that's going to be on this side. It's just that I didn't copy the question or the statement, but this block, the 4 kg block, it does have frictional force. And the other thing that it has, it is the Fg parallel. In some memorandums, you don't have to write the Fg parallel, but for you to know how to answer the questions and to identify the forces that are acting on the block, I would truly recommend that you actually draw your Fg parallel so that you don't forget about it. The other thing that we are having, obviously, it is going to be the normal force. And the other thing that we're obviously having, it is Fg. There's a difference between Fg parallel and Fg. Well, if you think of it, we do have something called the Fg perpendicular. It's actually acting something like this. It is actually called the Fg perpendicular, just on the opposite side of the normal force. So this is how you draw your free body diagram. These things have a lot of marks and there's nothing special about it. Well, let's look at the second question. The second question says we need to calculate the tension T. Guys, when you want to calculate the tension T, which block do you use between the 4 kg block and the 7 kg block? Remember, this also has friction, but we do not know the value of the friction. I mean, like, if you think about it, how can you calculate tension using the 4 kg block if you do not know friction? But if you look at the 7 kg block, you have acceleration, you have got the force applied, you have friction. Like, the only thing that is left, it is literally the tension. So just use this block. So you're going to say, well, the F net of the 7 kg block, it is just going to equals to MA. And you realize that I am having the force and I'm donating these forces from the free body diagram. And you know that the tension is going to be minus because it's actually on the negative side or it is actually opposing the direction of motion. And then you are going to have Fk, and then you know this thing is going to equals to MA. What is the value of Fa? You realize that your Fa is going to be 5 1. You are looking for tension, and you realize that Fk is going to be 12. You are having your mass that is 7 multiplied by 1.23. All right. So what is 51 minus 12? Guys, don't charm anyone. We are not interested. Use your calculator because you end up making mistakes and losing marks for no reason. So just use your calculator and say, well, 51 minus 12 is going to give you a value of 39 minus t that actually equals 2. So just say 7 multiplied by 1.23. What is 7 multiplied by 1.23? It is going to give you a value of 8.61. So we want to take this value to the other side. We end up having minus t that equals to 8.61 minus 31. That equals to minus 30.39. So therefore you realize that your tension is the same as 30.39 newtons. Well, that was easy enough, right? I mean, like anyone could have actually followed through to what we're actually trying to find on this question of finding tension. Let's look at this one. They say we need to find the F net on the 4 kg block. How can we find the F net on the 4 kg block? You know that the F net on the 4 kg block, it is also going to equals to MA. Well, I mean, a lot of people can say, well, if I use tension minus friction minus Fg parallel, I could find the F net. But you do not know your value of Fk, so you're still having a problem. Guys, this thing is a system. If you're having a system, it actually moves with the same acceleration. I mean, if you're having a truck that is actually on hook of a tail, obviously the head and the tail are moving with the same speed. Same thing with it all, similar thing that is actually happening in here. So if the 7 kg block is actually accelerating with the velocity or with an acceleration of 1.2 meters per second squared, it means that also this one, it is having the same acceleration. So it's going to be the mass of the 4 kg block multiplied by 1.23. You realize they are sharing the acceleration because they are actually on a system, right? So you realize that the F net of the 4 kg block, it is none other than 4 multiplied by 9.2 newtons, right? Now let's look at the next question. They want us to find mu k. So what is mu k? It is the coefficient of kinetic friction of the 4 kg block. I tell a lot of people this, guys, the best way to know what to do is to know what you, okay, the best way to know what to do is to know where to start. I mean, they want you to calculate mu k. What are the necessary calculations that I need to do in order for me to find mu k? Because this is the problem that a lot of people have. It's not that they do not understand Newton's laws of motion. It's just that when they see a question, they do not know where to start. But Marvel want to teach you where to start. Well, you want to find mu k. Which formula consists of mu k? You realize that, well, I have this wonderful formula called kinetic friction equals to mu k multiplied by the normal force. First of all, in order for you to calculate mu k, you need to know normal force. What is the normal force? Well, the normal force is going to equals to mg the cos of theta. Where's this thing coming from? Well, the normal force is always opposite some forces acting onto it. For example, let's have this block on a plane. If you were to draw a free body diagram of this block, you realize that this block, let's just call it block M for Marvel, is going to have a normal force acting upwards and Fg that is actually acting downwards. So what is the normal force of this block? You realize that the normal force of block M is equals to mg. You realize that this force of mg of Fg is the same as the normal force. They are actually acting opposite to one another, so they are actually equal. There is a scientific explanation, but I do not want to get into that. But let's look at this one. You realize that on this one, we are having normal force opposing the Fg perpendicular. But what is the value of Fg perpendicular? So Fg perpendicular, it is just mg the cos of theta. I don't want to explain where this is coming from in this video, but so you realize that normal force is the same as Fg perpendicular. That is where it's coming from. If here normal force is opposite with Fg, normal force equals to mg. So on this situation, on this type of problems, normal force is opposite to the FG perpendicular. So normal force just equals to the FG perpendicular. So the formula of the FG perpendicular is mg, the cos of theta. So this is the value of the normal force. That's the first thing to do. Calculate the normal force. What is the value of m? Is the 4 kg block multiplied by 9.8, the cos. What is the value of theta? The value of theta is 18 kg. Oh, 18 degrees. So that becomes your 18 degrees. So you end up having 4 multiplied by 9.8, the cos of 18. What do you have? You have your normal force equals to 37.28 newtons, right? So now, okay, you're great. You now have normal force. Now you need to figure out a way to find frictional force. How do you find frictional force? You need to go back to your free body diagram. You realize, well, if I can say F net of the 4 kg block actually equals to MA. Well, you realize that you do have that F net. You've already calculated it. But if I want to calculate the tension, the frictional force, what should I do? I know that I'm going to have the tension. It's on the positive side. On the negative side, I'm looking for friction, and I'm also having my FG parallel. What is FG parallel? So your FG parallel equals to mg, the sine of theta. So for FG parallel, instead of writing FG parallel here, you can just write your mg, the sine of theta, and this thing actually equals to your ma. You realize that, well, here I said MA is the same as 4 multiplied by 1.23. So we can do something similar. But what is the value of tension? We've already calculated tension to be 30.39. We are looking for frictional force. What is mg sine of theta? M is 4 multiplied by 9.8, the sine of 18 degrees. Yes, the 18 that I'm talking about. And you realize that MA, we have already said it equals to 4.92. So I'm just going to put 4.92 in here. So let me just add this to 30.39, and then I subtract it with this value. So I'm going to say, well, 30.39 minus 4 multiplied by 9.8, the sine of 18 degrees. What do I have? I have a value of 18.27 minus FK, that actually equals to 4.92. So I want to take this to the other side. What do I have? I have minus FK, that's going to equals to, I'm just going to say 4.92, and then I subtract this value. I end up having friction that's minus 13.36 newtons. So now you are having your FK. So now your formula is complete. You are having FK and you're having your normal force. So if you substitute, you can find mu k. So if I say Fk equals to mu k multiplied by normal force, if I divide both sides by the normal force, I find that mu k is the same as friction, and my friction is just 13.36 divided by the normal force, that is 37.28. So what is the value of the kinetic or whatever? So it's going to be 13.36 divided by 37.28, and the value that I find, it is 3.358. So this thing, it doesn't have, well, you can actually round it off and say, well, this is similar to 0.36 if you want. So it doesn't have the SI units, because when you divide, the newtons actually cancel out and doesn't have the SI units. So this is how you actually deal with this wonderful question. Oh, this is the last question. Identify a Newton third law pair on the 7 kg block. Well, number one, what is Newton third law? If you think of it, Newton third law says if body A exerts a force on body B will exert the same force on body A but opposite in direction. So you're just looking for those forces. Which forces are exerting the same amount of force within the 7 kg block but acting on opposite direction? You just look at your free body diagram. Obviously, it is actually the normal force and Fg. That's the first one. These two are a pair. They are equal but acting in opposite direction. Then the other one, you can say it is the force of the ground on the block as well as the weight of the 7 kg block. So this just comes back here. So guys, if you need assistance with this, just text this wonderful number and we're going to help you with everything that you need to know on preparing your physical sciences. So just ensure that you check with us today.